Here we are given the graph of y equals f of x and asked to graph y equals f of x minus 4. In this case, we have y equals f of x going to y equals f of x minus 4. The x minus 4 is the inner function, and it is going to cause the original graph to move 4 units to the right. It looks for its values at the left. So 0, 4 will move to 4, 0. 2, 4 will move to 6, 4. And 4, 0 will move to 8, 0. The blue graph is y equals f of x minus 4. The next example is to graph y equals 4 less than f of x. So this time we start with y equals f of x, and we go to y equals f of x minus 4. We see that the f of x is intact in both. That means the changes are going to be in the y coordinates, and because we're taking each y coordinate and subtracting 4, we'll be going 4 down. So 0, 0 will go to 0, negative 4. 2, 4 will go to 2, 0. 4, 0 will go to 4, negative 4. The blue graph shows y equals 4 less than f of x. The next one is y equals 2 times f of x. So starting with y equals f of x, we're going to y equals 2 times f of x. The f of x is intact. That indicates that all the y values are going to be multiplied by 2. So we're going to stretch vertically by a factor of 2. Now that means we're going to multiply the y coordinates by 2, and when we take the 0 in the 1, 0 and in the 4, 0 and multiply them by 2, we get 0 again. So those 2 points are not going to change. But here we have 2, 4. When we multiply the 4 by 2, we get 2, 8. So the new curve is shown in blue here. The original range was from 0 to 4. The new range for y equals 2f of x is 0 to 8. We have more examples. For y equals the opposite of f of x plus 3, we start with y equals f of x. we go to y equals the opposite of f of x, and then we add 3 to the opposite of f of x. The f of x is intact from the first function to the second, so we're acting upon the y values. They're going to be multiplied by -1, which is going to reflect the curve over the x-axis, and the opposite of f of x is intact from the second to the third function, so we're going to be adding 3 to those y values. That will move our graph up 3 units. So when we reflect our original graph across the x-axis, we're multiplying the y values by -1, so the points on the x-axis do not move. But the point 2, 4 will go to 2, -4. This is an intermediate curve. Now we're going to go up 3, and so 0, 0 will go to 0, 3. 4, 0 will go to 4, 3. And 2, -4 will go to 2, -1. So the solid blue function is the final result. We have 2 more examples. In this next one, we start with y equals f of x, and replace the x by its opposite. That's the same as saying we've multiplied the x by -1, all the x values. We're going to reflect horizontally over the y-axis. So 2, 4 will go to -2, 4. 4, 0 will go to -4, 0. 0, 0 again stays at 0, 0, because when we take -1 times 0, we get 0 again. So the resulting graph is in the second quadrant. The domain of the original, of the red one, is from 0 to 4. The domain of the final one is from -4 to 0, assuming that there are no arrows involved, that the graph just is where it appears to be. And in this last example, we start with y equals f of x. We replace the x with x minus 5, and then we replace f of x minus 5 with f of x minus 5 times 1/2. So the first step, we're going to go 5 to the right. The second, we're going to shrink vertically by a factor of 1/2. All of the y values are being multiplied by 1/2. So first of all, we go 5 to the right. So 0, 0 goes to 5, 0. 2, 4 goes to 7, 4. And 4, 0 goes to 9, 0. So this is our intermediate step. But now the y values are going to be multiplied by 1/2. That's not going to affect the two bottom points, but the point 7, 4 will come down to 7, 2. The final graph will be down here. The final graph, the blue one, has domain from 5 to 9 and range from 0 to 2. Remember, you always have the larger number at the right.